Welcome to another episode of ThinkBox Radio, a podcast inspired by Sears ThinkBox, the innovation center at Case Western Reserve University. Our goal is to share some of the magic that happens at the Case School of Engineering and to inspire your own innovations and startups. ThinkBox Radio is produced by Abby Murphy and is sponsored by the Case Alumni Association. Now, let's meet our host, Robert Smith, the former economic development reporter for the Cleveland Plain Dealer.
Hello, everybody, and welcome to another edition of ThinkBox Radio, the podcast that asks, why didn't you do this in school? So we're in a biology lab in Millis Hall in the College of Arts and Sciences, and our special guest today is Joy Ward, research catalyst extraordinaire. Joy is a biologist, a climate scientist, and the dean of the College of Arts and Sciences. She came here 3 years ago from the University of Kansas and immediately began expanding research opportunities for our students with some eye-opening results. So we're really excited to have her on the show. Joy, welcome to ThinkBox Radio.
Thanks, Bob. It's really wonderful to be here. I was looking forward to talking with you today.
One of the things you started at Case right away is something they call the Expanding Horizon Initiatives.
That's correct.
Tell us about that.
Thanks for asking about that initiative because it is near and dear to my heart. So certainly when I was a student, one of the most critical ways that I learned was working side by side with faculty mentors in the process of learning how to be a scientist. I gained a lot from the classroom, but I really learned how to be a scientist in that process of just doing the hard work, asking the questions and doing the experiments. And so I took that idea with me and developed a program whereby faculty can propose their newest and best ideas to us, but they also have to include a plan on how they will mentor students in the process. And then we bring them all together and fund the best proposals, and that enables the faculty to have financial resources to support the project and the student to do the work together.
Nice. What's the reaction been amongst the students? And are we talking undergraduate students?
It's both graduate students and undergraduate students. So it depends on who the faculty member wants to include on their team. And the students tell us, whether it's students here today that are engaging in this process or our donors that maybe were here 40, 50 years ago, they tell us that that one-on-one interaction with faculty and that mentoring that they get is why they are where they are today. And so we're just trying to really support what the faculty already do in developing innovative ideas in their research and then bringing the students along with them.
Let's give folks an idea of what Expanding Horizons has given us. I have a list of some of your projects here, and one that jumps out at me, now it has the big academic title, I'm going to read it here, Machine Learning on Surface Topography for Painting Attribution and Conservation. But the press is calling this art fingerprinting. And I think it was Ken Singer in physics, working with artists and art historians, came up with an algorithm that can read the brush stroke of a painter.
It's fascinating. And I was so grateful that Professor Singer and Professor Betsy Bowman in art history actually came together for this project. And the key idea that led to this innovation were students. Their students were the ones that came up with the question.
How so? I mean, why?
They wanted to know, how do we attribute art? Is there a new way? So, for example, when a crime is committed, we use DNA fingerprinting to figure out who might the subject have been of the crime. But this is similar in that we can read the brushstrokes using physics techniques and potentially attribute a given piece of a painting or an entire work to the appropriate artist. And the idea here from the publication and follow-up in the media was that people believe that this will be the new direction in art attribution because of two professors and students coming together.
So I once took a lunchtime art class over at the Art Museum, which you can do when you work at Case. And I thought it was interesting. They would show us a painting and they'd say, we think this was done by Rembrandt. And I'd say, well, what do you mean you think? And they'd say, well, it was done by his studio. I didn't realize there's teams of artists that would work with the master. And is that one of the reasons? I mean, is that one of the uses of this technology? we would now know maybe who did that mural that's famous.
That's right. And for example, they're now analyzing some El Greco paintings to see if it really was the master doing the entire painting, or were portions done by students, maybe after he went to sleep at night, for example. And so the way they do that is they use an instrument that can pick up subtle changes in topography of the paint, much like mountains and valleys, but in this case it's small scale. And we believe that, and the evidence from this work shows that a given artist may have a signature in how they press the brush that identifies them uniquely from others.
There's going to be some happy people and some disappointed people.
Understandably, yes. The art market is huge, and this could transform that.
How accurate is it?
In the high 90s.
No
so
kidding.
Very
so
exciting.
Like fingerprinting.
Yes, it is.
Okay.
It is.
So that's a great example of liberal arts working with physics. A modest project. I think you guys gave them $30,000 and they pulled in students. But part of the idea, I think, is also to attract more outside funding with these by kickstarting their project.
Yes, so once a faculty member receives one of these grants, and I will add that they are funded by our donors, so the donor is really part of the team on this. But once a faculty is chosen through a very challenging competitive process where faculty form a committee and pick the top proposals, once they are selected, and they have to do three things. Obviously, the project itself. They also have to apply for external funding using the results of the funded project. And of course, they have to mentor students in the process.
Okay. And how much time do they have? Is like the clock ticking?
We give the projects a year, but if they need time to go over, for example, during COVID, there were faculty that couldn't travel to meet the needs of the project. We are pretty generous with extensions. We just want to get the work done in the best way that the faculty member believes it should be.
Okay, so here's another one that looks interesting. I don't know this one real well. Immersive dance performance using laser projection, motion tracking, and spatial audio in dance.
Yes, very exciting. This was an innovation by our faculty in the dance department, and this is using a laser technique whereby the laser actually follows the dancer, and this involves physics components to this. Rather than in the past where a dancer had to learn what lighting would do and what a laser would do, in this case, the laser learns the dancer's movements and then follows the dancer. And that way, it's really more about the art than it is about the technology. So the technology enhances the art rather than the art having to kind of succumb to the technology.
How would it enhance the art? Is it like a training device?
No, it actually enhances the performance. And so whatever message the dancer is trying to deliver to the audience, it is enhanced by the movements of the laser. It really accentuates the message that the dancer is trying to deliver through the art.
Are they using this? Could we go see it?
Absolutely. You may see it. The last performance used it in several of the pieces, and it was incredible, the impact. I encourage everybody to see Department of Dance and all of our arts performances. They are outstanding, and our students do a wonderful job.
And what a great way to discover the school and all the different areas of expertise here when they come together on a research project.
It is exciting.
Cool.
It truly is wonderful. And I give our faculty really that credit for working with the students one-on-one to really train this next generation, educate the next generation in the art or in the scholarship or research that they do. This is what we need to transfer that knowledge to the next generation.
So Joy, how did this start? How did you get Expanding Horizons going?
I was very appreciative that the president and provost's office contributed the initial funds, about $250,000, to get it started, to get the first projects funded so that we could show proof of concept
But did you pitch it, after you arrived here?
I did.
Okay.
I had the idea as I was coming in to really build on that connection between faculty and students, and they were supportive. And so we used that $250,000 to now advance this to $8 million of generous donations from our most loyal supporters. And I think donors give because they want to be on that student-faculty team. They want to be part of that research or scholarship endeavor. And at Homecoming this past year, we had one of our highlights of Homecoming was a program called Ignite, where we brought all of our donors back to campus. And the students did posters on all of their projects and showed the donors what they were able to accomplish with their resources. It was so fun.
So it sounds like donors can pick the area they want to support. And I'm assuming it doesn't have to be a big gift, because I see a lot of the projects seem to range in price from $3,000 to $30,000.
Yes, it can be a small gift, yeah. So it's really accessible to a lot of different donors.
Okay.
And
you've attracted how much money to date?
Nearly $8 million.
Oh my, okay. So there's interest.
Yes, absolutely, absolutely.
So I see you've attracted almost $8 million in funding. You've already funded 40 projects, over 100 students involved. It's busy already. At full flower, what do you see this program becoming?
Yes, so our goal is to attract about $12 million in funding to meet our final goal. And that would allow for us to give out $500,000 every year in projects, so that we could support between 30 and 40 projects and 100 students every year. Those statistics that you read were for multiple years of this project. We would like to do that each and every year.
Oh my, okay. We're going to switch gears here and get a little more personal. So everyone wants to see more women in science. I know we're trying to get my 16-year-old daughter to consider STEM. And you're obviously fascinated with the field, and you worked your way up to the top, dean at a highly ranked research university. Tell us what got you interested in science in the first place.
My love for science goes way back to when I was a little child. I was that child that was in the rocks and in the dirt and just was always exploring my yard and trying to find animals and learn more about them. And also my love for science really came about when my late father, was a physician, and he gave me his old microscope from his medical school days, and I would always be looking at plants. I probably was seeing air bubbles in our plants, but I thought it was water moving through the plants, which I had studied, and it really awoken a love for science. But really what allowed me to be successful was my mentors. And that began early on in high school with Ronald Thomas telling me that if I wanted to be a scientist, that's what I should do, and not in any way holding me back.
And who was Mr. Thomas?
He was a wonderful teacher at my high school.
All right, the importance of teachers.
That's
again.
right. All the way to undergraduate times at Penn State with professors like Jim Windsor and Andy Stevenson that taught me how to do research and how to do statistics and how to write critical pieces of knowledge to be successful. And then into my PhD at Duke University with Boyd Strain, who is a phenomenal advisor and a still close friend to this day. And then Jim Elringer at the University of Utah. So all along the way, these mentors teach you more and more and reveal what the profession is really like, how to be successful, and help build your skills along the way.
Cool. Now, a book could be a mentor. Could you recommend a book or an author for parents who want to get daughters interested in STEM?
I would suggest Lab Girl. That's a good one, particularly for young women that are teenagers that are interested in science. That's one I would check out.
And what is it you like
any
about that?
books on being a naturalist. I think that really awakens a love for nature as they're learning how ecosystems work. I used to buy lots of nature guides for my kids.
Okay.
And they use those and they go out and explore with them. So that's
Okay.
another good way to go.
Okay. So, Joy, you're a biologist who specializes in plants and how they handle changing climates, which would seem to be a hot skill right now. What do you see happening to our planet with global warming, and how can science help?
Yes. I have been teaching classes on how our environment is changing and how plants are responding to that since about 1991. So way early on in that interest for our students. It's important to realize that the planet is changing, and it's changing much faster than we had predicted. Every time we update the models, it appears that change is actually ramping up. And it is challenging for plants because they can't just migrate like many animals can to meet a changing climate, for example. And so we will see interactions where plants actually experience physiological stress, not emotional stress like we have, but physiological stress. We will see cases where plants become more physiological stressed, and they may be more vulnerable to other pests, for example. We're seeing that right now with temperature changes. They can be stressed in their physiology and their ability to do photosynthesis. And we're also seeing reproductive changes where plants aren't flowering at the same time as they used to. And that could set off changes in cues between, for example, plants and pollinators. The time that flowers open might not be the arrival time for pollinators. So we're worried about kind of those mismatches and how things may be changing at different rates. And also we're worried about extreme events like floods or droughts or those kinds of things that can really have impacts on plants and crops and under large scales.
So those changes you can see in plants, how does that help us address climate change?
Well, what we can do in my work, for example, we can look back into the past and we can understand how did plants respond in the geologic record to changing climates or to changing carbon dioxide levels, and then get an understanding of how plants may be able to acclimate or adapt to that today.
Interesting, yes. So the university is getting more and more in climate science. What would be our areas of expertise here in CASE?
We have, for example, faculty that understand ecosystems and look at how they change under a changing planet, and in particular look at below ground processes. Those microorganisms that live underground are strong drivers of how plants and ecosystems function. So we have experts in that area. We have experts that focus on biodiversity and how we're seeing extinctions and what might drive those extinctions into the future. And then we have faculty that are concerned with energy and how our energy needs interact with the sustainability of our planet.
Well, we know they're going to have a lot of work to do, and it's good to know they're working on it.
That's right.
So, Joy, you're helping to shape the vision for a $300 million research building on Case Quad. And this is going to be our first new research building in a generation. I understand it's going to be interdisciplinary, bringing in students and faculty from all the different colleges and departments. Tell us some of your vision for that new building.
Yes, certainly. It is a game changer for us on the College of Arts and Sciences. And this building is mainly focused on bringing scientists and engineers together all under one roof. And we're also going to add in faculty that are involved in the humanities and the arts, because we really believe that having those analytical minds coupled with creative minds and bringing that way of thinking together is really going to help be most innovative to solving some of society's biggest challenges. And so we're very excited about that. And this building is going to be a place where we're not just moving whole departments into the building, we're moving people that are focused on solving specific challenges, specific problems in our world, like combating disease and understanding how to sustain ecosystems, understanding how the brain works, understanding, like I said, meeting our energy needs. So we'll bring those thinkers together along with students who will do research side by side with faculty and really work on tackling those issues. And what I love about it is we can move all the way from foundational approaches in science and engineering to applied, and all the way through from basic to applied, and really have the full mechanistic through applied understanding of any problem we're trying to challenge, we're challenged with.
That sounds dynamic. So could you give us any examples of the kind of resources researchers might find in this new building?
Yeah, so we would have labs that would be more like an individual faculty member's lab. We'll also have core facilities where not only the faculty in that building can use those core facilities, but faculty from all over campus can come in for expertise, NMR, or other equipment that might be crucial to their research. So we want this building to be more engaging beyond just those in it, but a resource for the whole campus.
Okay, that sounds exciting. And the news never ends with Joy Ward. We just announced by the university that you guys have attracted a $2 million grant, I believe, from the Mandel Foundation to start a new major, experimental humanities. Tell us about that.
Yes, very exciting. And this was a team effort in the College of Arts and Sciences and driven by needs of our students. So our students have told us that we enjoy double majoring in, for example, a creative major and a more analytical major. We have a lot of science, art, science, humanities double majors, engineers in the arts and so forth. But our students have said, we would like to kind of bring those together, integrate those more. And that's what this major is designed to do. It has a foundation in the humanities, and the Mandel Foundation has been a strong supporter of the humanities at a national and international level. So the foundation is in the humanities, but we'll have those humanities students learning things in technology, like about artificial intelligence and about coding and how we might bring ethics into the technology sector. And we believe these students will be highly sought after because they'll have that critical thinking
Sure.
of the humanities and the communication skills, but be able to communicate with those in technology.
That's right. And they'll be, I'm assuming you'll see them tackling some of the world's problems using both technology and a humanity mindset.
Absolutely, absolutely.
That could be powerful. Okay.
And a lot of our corporate leaders have told me that we would hire humanities majors if they could just talk to those in technology. That's what we're looking for.
All right.
And so we're excited about this possibility.
Oh, that sounds great. So Joy, you've been here 3 years. Your husband Rob is on the staff as a professor of biology. I think you guys have 2 kids. How have you been liking Cleveland, and how have you been liking Case?
Yes, we are Cleveland fans.
We like to hear that.
We had not lived here before, but we absolutely are loving our time here. Rob, being a professor in biology, has found the students here to be wonderful, faculty colleagues to be engaging and very, very welcoming. So even from day one, we were just so warmly welcomed onto this campus.
That's
and are
good to
so
hear.
grateful for that. Our daughter goes to Beaumont School. She's a 10th grader.
Great
and
school.
very excited about the arts that they have to offer there and the sciences. And then our son stayed back at the University of Kansas. He was well into his undergraduate years and will graduate in the spring as a classics major.
Okay.
So we also brought my mom with me,
all right.
Joyce, and she's been volunteering in the community and even doing some international mission trips with groups in Cleveland.
Oh,
so
awesome.
We are great fans and just appreciate the warm welcome we've experienced.
And I think the Botanical Garden roped you onto the board?
Yes, I'm on the
Okay.
board of the Arboretum and Gardens
Community
and so
engagement,
enjoy
great.
that. And Joe Keithley, I think, was key for support in bringing me onto that board, and I want to thank him for that and his support. So
All right.
It's been a lot of fun to be on.
Oh, that's great to hear. So you've done so much in 3 years, and we know there's a lot more to come. So thanks for being with us today, Joy.
Oh, you're welcome.
That is going to conclude another edition of ThinkBox Radio here at Case Western Reserve University, where our motto is, think beyond the possible.
And that concludes another episode of ThinkBox Radio, stories inspired by America's leading college innovation center. Thanks for listening. You can find past episodes on our website, casealumni.org. Goodbye from Case Western Reserve University, where our motto is, think beyond the possible.